Mice pie. Mice never tasted so delicious.
Well, today we're going to talk about a very important concept in probability and statistics, that is random variable. Now, this random variable is conceptually different from the variables we learned in calculus, in algebra. It is called random variable. Now, what is a random variable? In order to fully understand what a random variable is, we need to first introduce another closely related concept, that is random experiment. So what is a random experiment? A random experiment, by definition, is simply a process or procedure that has more than one possible outcomes. That is the definition of a random experiment. So, for instance, if we flip a coin, so we will get, there are two possible outcomes. One possible outcome is we may get a head. The second outcome is tail. So in this case, we have two possible outcomes. Two possible outcomes. So therefore, flip a coin is, by definition, a random experiment because it has more than one possible outcomes. Now, another example is, say, roll a die. Right, roll a die. So in this roll a die, we want to see that the face value on the top. So in this case, the possible outcomes are 1, 2, 3, 4, 5, or 6. So there are 6 possible outcomes. Therefore, it is a random experiment. Now, as you can see, as long as a process or procedure has more than one possible outcomes, it is, by definition, a random experiment. And you will see that there are many such random experiments in life, right? So here I give just 2 very simple examples. Now, for a random experiment, we have another concept, so-called the sample space of a random experiment. So what is a sample space of a random experiment? Now, by definition, the sample space is the set of all possible outcomes. Then, for instance, if we flip a coin for this example, the sample space, well, is usually denoted by the capital letter S. All right, for flip a coin, the sample space is simply S equals the set of head and tail. So it is a set consisting of all possible outcomes. For the second random experiment, the sample space will be, all right, the set 1, 2, 3, 4, 5, and 6. All right, so we introduced the concept of random experiment. Okay, it is a process or procedure that has more than one possible outcomes. And the sample space of a random experiment consists of It's a set consisting of all possible outcomes. Now, we're ready to talk about the random variable. So, what is a random variable? So, random variable, by definition, it is simply a real-valued function defined on the sample space, S. All right, so this random variable just assigns a real value to each outcome in the sample space S. Okay, so now let's just give let's give an example here. Flip a coin. We know that the sample space is a set consisting of head or tails. Okay, so this is our sample space. Then if we let x equals 1, if we got a head, or 0 if we got a tail. So x here is a function. All right, it assigns the outcome head a value, a real value 1. X equals 1 when you got a head, and x equals 2 when you got a tail. So it is a random variable. The value of x depends on the outcome of this random experiment. If we got a head, then x equals 1. If we got a tail, then the value of x is 0. In that sense, it is a random variable. For another example, say roll a die. Now, in this example, the sample space is 1, 2, 3, 4, 5, and 6. Now, this is the sample space of this random experiment. The possible outcomes are 1 through 6. Now, let's define a random variable. Say x equals 1 if it takes, if what? We have 1, 2, or 3, all right? So it equals 0 if 4 or 5, and equals 1, or if what? Outcome is 6. So -1 here, right? It equals -1. Now you can see here x is a random variable. It assigns a real number to each possible outcomes here in the sample space S. Okay, assigns 1 to the outcomes 1, 2, 3, assigns 0 to the outcomes 4 and 5. It assigns -1 to the outcome 6. So by definition, x is a random variable. All right, it takes different values based on the different possible outcomes of this random experiment. So that is the definition of random variable. This random variable is conceptually different from the variables we learned in calculus or algebra. Now, the main difference is random variable is associated with a random experiment. It can take different values based on the different outcomes of a random experiment.